So we're going to continue our work with logarithms, probably looking at some examples that might be a little bit more complicated, just so we can talk through how these get simplified. Alright, so remember we always set it equal to x. Log base 8 of the square root of 2 is equal to something. So we put it in exponent form. Start with your base of 8 raised to the x power is equal to square root of 2. Alright, well that square root of 2 is the same thing as 2 to the 1/2 power. Again, we do want these to have the same base, and we see an 8 can be written as a base of 2. 2 raised to the 3rd power, and then the x goes out there. So all that I did was I rewrote 8 as 2 to the 3rd power. It still has an exponent of x. So 2 to the 3rd power to the x power is really 2 to the 3x power is equal to 2 to the 1/2 power. Alright, once you get that base to be the same, then you know that the exponents will also be equal. So we can just go ahead and write out that equation, 3x equals 1 over 2. So, a couple ways you can do this. Easiest might be is just do the fraction trick to get rid of that, that fraction. So we have 6x is equal to 2 times 1 is 2, divided by 2 is 1. Divide both sides by 6 now to get the x alone, and we get 1 over 6. So the value of our logarithm is 1/6. Alright, next example, let's go ahead and write it in exponent form. We have a base of 5 raised to the x power is equal to the cube root of 25. So, two things we want to fix here. We want this 25 in base 5, and we don't want this cube root. So let's take a look at this. The cube root of 25 is equal to 25 raised to the 1/3 power. Well, can we write 25 with a base of 5? Yeah, we can do that. That means that's just 5 squared raised to the 1/3 power. So again, we're just manipulating how this works so that we can get it to match the base that we have on the left side. Well, now that we have 5 squared to the 1/3, exponent properties would tell us to multiply that. 2 times 1/3 is 2/3. And this 5 to the x power is on the left side. So we have the same base, we're good, which means our exponents must be equal. So x is equal to 2/3. Our logarithm has a value of 2/3. Alright, moving right along, we know how to set that equal to x. Start with your base, 1/2 raised to the x power is equal to 8. So we're going to continue what we were doing with fractions in another video. 1/2, 2 has a positive exponent. We basically want that to go up top so we don't have that fraction. So that's equal to 2 to the -1 power, because that one exponent turned positive. To the x equals, I'm going to go ahead and write this as a base of 2 since I can see I'm getting a base of 2 over here on the left. So it's going to be equal to 2 to the 3rd power. So we have 2 to the -x, I just went ahead and multiplied -1 times x is equal to 2 to the 3rd power. So our bases are the same, which means our exponents are the same. So we have -x is equal to 3. Divide both sides by -1, and x is equal to a -3. So our logarithm has a value of -3. Alright, so these 3 examples, our last 3 examples, you can see that they're already, this is a logarithm equation. The variable is in a different spot, and they already told us the value of the log, what it equals. So we will take our knowledge of logarithms, go ahead and rewrite this in exponent form. Log base 5 of x is equal to 3 tells us that 5 raised to the 3rd power is going to equal x. Well, what is 5 raised to the 3rd power? 125. So x is 125. Next example, log base 2 of x equals 3.5, so we rewrite it. 2 raised to the 3.5 power is equal to x. All right, so we're gonna manipulate this 3.5, and we are gonna go ahead and break this apart. 3.5 is the same thing as 3 plus a half, right? 3 plus 1/2 is 3.5. So we can rewrite this as 2 to the third power times 2 to the 1/2 power is equal to x. What this allows us to do, or we're allowed to do that because we know that if you're multiplying the same base, you would keep the same base and add your exponent. So we just took our exponent, broke it apart with addition, which means those would each get a base of 2. So why is this helpful? Well, we know that 2 to the third power is 8, and 2 to the 1/2 power is the square root of 2, and now we're getting a nice exact value for x, and we don't need to round for a decimal. All right, last example. Let's go ahead and put this in exponent form. We have our base of 1 over 25 raised to the negative 1/2 power is equal to x. All right, so here is what we're looking at with this one. You have a negative exponent, so you would say 1 over 25 to the positive 1/2 power. Well, what is 1 over 25 to the positive 1/2 power? That is the same thing as saying the square root of 1/25. And what's the square root of 1/25? Oops. 1 over square root of 1 is 1, square root of 25 is 5. 1 over 1/5, we would deal with this mathematically by saying that's 1 over 1 times 5 over 1, because we would flip and multiply that division with the fraction, and we would get 5. So x is equal to 5. That's the long way to do it. That's the mathematical way. The shortcut way says that you can take this and flip the 1 over 25 to get 25 and keep your make your exponent positive. 25 to the 1/2 power is the same thing as square root of 25, which is 5. So a couple ways to get there.